Inequalities. Linear inequalities. What does linear mean? Line. Yo. Oh, one. Thank you. One solution, and to what degree? First degree. So you see it's x to the first power. If you multiply or divide both sides by a negative, what must you do? Flip the sign. So in our first problem, we have negative 2x minus 7 is less than 9. I'm going to add the 7, and I have negative 2x is less than 16. I divide by negative 2. Do I flip the sign? Yes, and I get x is greater than negative 8. There's three ways to write solutions. You can, number one, write the inequality, or number two, you can make a graph. Or number three, you can represent it in interval notation. All review, correct? So the first part of your assignment will be dealing with linear inequalities where you add, subtract, multiply, divide. This is just a review. I did one problem because it's kind of prerequisite for this class. We should know how this thing works, okay? All right, the second one, compound inequalities. Compound means more than one. Very good. It says solve and graph following inequalities and represent the solution set in interval notation. This is a conjunction. Conjunction is where it comes together. It's an intersection. A disjunction is where they go apart, and it's a union. So conjunction, in this situation, we take that as one inequality, 3x minus 7 is greater than negative 9. And then we'll grab the other one. 3x minus 7 is less than or equal to 11. So I choose to make two inequalities out of it. Some people will add 7 to both and divide everything through by 3. If you want to do that, go ahead. It's not the way I do it, not the way I teach it. So I'm going to solve each. I will add 7 to both sides. 3x is greater than negative 2. I'm dividing a negative. Should I switch the sign? Why? Not dividing by a negative. So therefore, we leave it alone. Well stated, Mr. Peterson. Add 7. 3x less than or equal to 18. X less than or equal to 6. So this means both things must be true. X must be greater than negative 2/3, and x must be less than or equal to 6. Can you give me an example of a number that's greater than negative 2/3 but less than or equal to 6? Sure, 1 works. We'll see that in our solution set. Open circle, arrow to the left. Closed circle, arrow to the right. I've expressed the answer as an inequality. Okay, x is greater than negative 2/3 and less than 6. You could also write it like this as you practiced before. Okay, so you see the inequalities, you see the graph, and then I have interval notation, negative 2/3, 6, bracket. Any question on that example? Okie doke. Let's try a disjunction. If I divide both sides by negative 4, what do I have to do? Flip the sign. I come up with these two, and the word or sits between them. That means only one or the other needs to be true. They don't both have to be true, but just one or the other. So as we graph this, plot negative 5 and negative 2, x greater than negative 2, or x less than negative 5. Can anybody try to think of the mistake that people might make when they graph this? Why? Because they put the negative 2 here and the negative 5 there, right? I mean, that would be normal for people to want to put the negative 2 here and the negative 5 there. But you know that's problematic because it should be a disjunction. They should go apart. Okay. So one or the other must be true. I have my inequality, I have my graph, and then to show the interval notation, negative infinity to negative 5, union with negative 2 to infinity. We write that U symbol in the middle. Some people ask, do we have to do that? Yeah, yep, yeah, you do. Mathematical notation. You'll use that moving forward. Got it? Okay, flip it over. We're going to do 3 more examples, and then you have time to work. Non-linear inequalities. What does it mean to be non-linear? It is on the number line, but the exponent is not 1. And here the exponent is 2. Getting crazy over there. All right, so here's the deal. Your rules for inequalities go out the window, folks. Okay? It goes out the window when you're talking about nonlinear inequalities. This is where people make mistakes on their test. And I'll show you exactly what they do. Okay? Here's what they love to do. X squared plus 2x is greater than 15. I'll factor out the x plus 2 is greater than 15. That means x is greater than 15 and x plus 2 is greater than 15. So therefore, x is greater than 15 and x is greater than 13. You graph it, you're like 13 and you're 15 and you go that way and you go that way and you say good enough for me. Totally wrong. See the voodoo math? That's voodoo math. It's totally made up. Okay? You could write a book on it, but nobody would buy it. So let's do real math. Non-linear inequalities. First rule, must set equal to 0. I don't want to over dramatize the situation. All right. Now, then you have 2 options. And it's different, folks. Tomorrow we're going to do something different. But here's the first option. This option will always work. Stop yawning. All right. Number line test. That's our first option. I have x squared plus 2x minus 15 is greater than 0. First, you got to think about, what is the question even asking? What does it mean to be greater than 0? What does it mean to be greater than 0? To not be negative. If you're not negative, you're positive. We're positive, right? It's asking, where is this thing positive? I don't know. Pick a number. Pick one. 2. 2 squared is 4. Plus 2 times 2, that's 4. So that's 8. 8 minus 15 is negative 7. Negative 7 is not greater than 0. So I know 2 doesn't work. 3. Okay, so 3 squared 9. 6. 15 minus 15 is 0. 0 is not greater than 0. So 3 doesn't work either. 4 works. That would be a pain to do it like that, wouldn't it? Let's factor it. What's it factor to? Plus 5 minus 3, negative 5, positive 3. That's where it is 0 right there. It is 0 there. So reason this through with me. A little bit of logic, folks. If it's equal to 0 at those spots, then it must be either positive or negative between those spots, right? So we will test on our number line. What's a number to the left of negative 5 you can plug in? Okay, so let's plug in negative 10. Negative 10 plus 5. Is that positive or negative? Negative. And negative 10 minus 3, positive or negative? Negative. So you would have a negative times a negative. What's a negative times a negative? Positive. So therefore, we know that values to the left of -5 will be positive. Give me a number between -5 and 3. Easiest number. 0. 0 plus 5, positive or negative? Positive. 0 minus 3, positive or negative? Positive times a negative is negative. So I know it's negative in between. Then we will do to the right of 3. Give me a number to the right of 3. 5. Great. 5 plus 5, positive, and 5 plus 3, or 5 minus 3, positive. Positive times a positive is a. So this number line test tells us for sure the numbers that will work and the numbers that will not. And so we have this little graph here, and I'm going to write the answer in interval notation. But first, I must answer the question. Is this question asking me where it's positive, or is it asking me where it's negative? Positive, because it's saying, when is this greater than 0? This part right here is my indication that I'm wondering where it's positive. So my answer is from -infinity to -5, union with 3 to infinity. No equal sign. No equal sign here, so no brackets. Got it? Okay, second way to do it is this. If you know what the graph looks like, graph it. What shape does this graph make? What? Say it louder like you own it. Parabola. Thank you, Jonah. This makes a parabola. Does this parabola go right side up or upside down? Right side up. Why does it go right side up? Because the x squared is positive. The coefficient in front of x squared is positive, so it goes right side up. Okay? Well, let's graph it. It's super easy to graph it. Just go x plus 5 and x minus 3. So we got those two pieces. You're going to plot -5 and +3. That's where it crosses the x-axis, correct? And then I know that the parabola goes up. And it passes right through those spots. You told me before, I said, what does it mean to be positive? And you said, no, I said, what does it mean to be greater than 0? And you said that it means you're positive. Well, that's on the number line. Graphically speaking, what does it mean to be greater than 0? It means you're above the x-axis. I'm above the x-axis here. I'm above the x-axis here. I'm below the x-axis here. So you can see by looking at your graph that your solution set is going to be from -infinity to -5, union with 3 to infinity. Same problem, same solution, two different ways of solving it. If you don't know what the graph looks like, you can't do it like this. Furthermore, some of you are saying, hey, I know it just switches positive and negative and positive all the time. So once I find one, I'll just flip the others. No, it doesn't. I could give you many examples where that's not true. Tomorrow, we're going to try to do this. We're going to try to do 5 over x minus x over x plus 2 is greater than or equal to 2. Do you know what that graph looks like? No, you have no idea. And so you can't make the graph. You got to make the number line, and you got to test, because there's not necessarily, it's not going to change every time. Sometimes we'll stay the same twice in a row. So you got to be careful. Did I make my point? Because some of you sitting there right now, you're going to previous memory, like, we've done this before. We've done this before. Not all of it, and not all in one day. So be careful. Be very, very careful. Okay, go to the bottom. Last one. Okay, we're going to do example 4. We'll get to the notes tomorrow on how to handle interval testing. But right now, we're going to do one of these as a graph. We're going to do one of them as a number line test. You get to choose. I'll let you choose. Do you want to do the graph here or a number line test? Graph? Okay, graph it. So, well, this is easy. I just factor it, x plus 4 and x minus 2. So I've got -4 and +2. Does this graph go up or down? Goes up. It's right side up because it's a positive x squared. Positive, 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 negative, 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 negative. Now, what's the question asking? Is it saying where is this graph above the x-axis, or is it saying where is the graph below the x-axis? Where is it below? Why? Because you got this less than zero piece there. So it's wondering where is it below? And where is it below? No brackets because there's no equal sign. See that? Okay, next one, number line test. First of all, what do you see right away that you don't like? I hate the negative, don't you? Let's get rid of it. Let's multiply through by a negative. Multiply through by -1, you're going to get positive 2x squared, get a minus 7x, you get a plus 5, and then what? Greater than or equal to 0 because you multiply by a negative. Does that factor? Yep. I'm going to do guess and check because I'm good at it. Otherwise, you can use the AC method. Is that right? Super. So what are my solutions? Where is it equal to 0? 1 and 5/2, which is 2.5, correct? So I'm going to set up my number line. I just put down a bunch of numbers. I got 1 and I got 2.5. Right? That's where I have to, that's where it's equal to 0, correct? So let's number line test. What's a number to the left of 1? 0. Positive or negative? Positive or negative? Negative times a negative? Positive. What's the number between 1 and 2.5? 2. Positive or negative? Negative, positive or negative? A negative times a positive? Negative. What's the number to the right of 2.5? 3. Positive or negative? Positive or negative? Positive times a positive? Now, I discard this original equation because I changed it. Is this question asking me where is it positive or where is it negative? Where is it positive due to this piece right here? So therefore, I grab the positive ones, and that would be from negative infinity to what? Union 5/2 infinity. Question. Or maybe you want to arm wrestle. Yeah. All right. Folks, for parabolas, 99% of the time, it does switch every time. Positive, negative, positive, negative, positive, negative, whatever. But you got to be careful. Do your testing. I'm sure it works out. So we're going to try much more difficult ones tomorrow. Positive, negative, positive? Not always. Oh, no, I'm sorry. You can always graph it. That's fine. What I'm trying to say is it won't always go positive, negative, positive. Sometimes it might go positive, positive. You might not see a switch. I could give you examples like that, but they don't come up real often. So anyway, I know you want an assignment. I'll give you an assignment. 1.7, page 87, 5 through 23 odd, and then 27 through 34. Okay. It's also written up here. You got the rest of the hour to work. I think, what are we at here? 105? 1? Yep, 1 o'clock, so you got 15 minutes. It's better than 0 minutes. Use your time wisely. You'll get a good start. It's key in college algebra to stay on top of your stuff. Good luck. Ready, set, go.